In this video here, I'm going to use the raster data model, the vector data model, and the triangulated irregular network as I explore IUPUI's campus. And what we're trying to do here is, how do we represent the surface? How do we show the topography? How do we show elevation across IUPUI's campus and the surrounding downtown Indianapolis area? In terms of where do I find this data, it's very easy. It's all available for free from the Indiana Spatial Data Portal, which is from gis.iu.edu. And to find these particular data sets, all I did was went to downloads, then single file download, went to my given area of study, Marion County, and in particular the area just west of downtown Indianapolis, and all I did was just click right there. And what then pops up is 32 available data sets. Those are different geographic spatial data sets that are available for us to explore. In this case, we're going to use the 2011 Indiana map data and expand that, and we're going to start off by using the Imagine Mosaic, which is a DEM of the Marion County using a 5-foot resolution. So it's a very, very good resolution, and so the pixels are going to be very, very small. So it's going to take a while to zoom into them, and so the resolution is quite high in this particular DEM. Later on, I'm going to use some LiDAR data, which is an LAS file, and these are very, 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 very big files. We're talking millions of points. And so because of that, the Indianapolis area that we're studying, which is just really the west side of the downtown Indianapolis area that includes IUPUI and the White River West Fork, is these 4 zipped files. So this just kind of gives you an idea as far as the massive size of the files that we'd be using here in a GIS. Going back to our map, in which we have, in this case, an example of the raster data model, just a base map here. This is an aerial image or a satellite image, and these here are examples of raster. So if I zoomed in this particular this particular image here, if I zoomed in close enough, you would see those grids. You would see those individual squares, cells, pixels, whatever you want to call them. And so that's very characteristic of the raster data model. So essentially, this is just showing not really elevation change, but instead, I guess, the surface differences. We got green areas where we have vegetation, dark green areas, forested areas, of course, gray areas, highways, parking lots, buildings. You have darker blue areas, rivers, and so those individual pixels represent whatever is there in terms of the surface. What we're going to do, though, is something you can't see here. You can't see elevation change in this particular raster image here. However, when we use the DEM from that previous website, using the plasma color ramp, which will be the theme that we'll see throughout this particular video, we see a pattern here. Darker blue or purple areas are lower elevation, and our higher elevation are shown here in yellow. And so these are representing feet above sea level. And so the river that goes right through the middle of the West Fork, and its kind of floodplain that surrounds it, we can see here kind of this low point right through the middle of the county, surrounded on both sides by relatively higher elevated areas on both sides of the West Fork of the White River and its corresponding floodplain. But if I zoomed in close enough, super close into this particular DEM here in GIS, you would see those squares. You would see a raster, and so you would see those regularly spaced squares or pixels, that grid pattern, and each of those represents a different color, of course, that we see in this particular color wheel. For example, I'm just going to click on this particular location. It's going to tell me that that individual pixel, it has a value or a elevation of 660 feet above sea level, whereas over here we have a different pixel value, 856. So if those represent a very, 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 very small square that, once again, I could zoom in and find, but it creates a very, very slow process and a slow video. I'll just have you take my word for it. So this particular raster image, we can then zoom into IUPUI's campus and start seeing some of the physical features, some of the landform features we see on our campus. And this is going to be one of the things, is what is the best way to represent a surface? Is the raster the best? Is the vector? Well, this depends on what your objective is. So in this case, the raster model is useful because you can see what the location here is of the river as far as the elevation. It's every single pixel is colored in as you're going to see later on when I show you a contour line, not every pixel is colored. And so you see a whole different way to represent the surface, as I'll show you here in a minute with the vector data model. But nonetheless, what this shows is we can see lower elevation, of course, the river. Everything, for the most part, slopes gently down our campus towards the river. If we zoom in here, you can see the Carroll Stadium football field. But then also what you can see is somewhat, as you can see, the grandstand. So a very steep change, and so we go from purple to dark here as we go down the bleachers towards the football pitch. Then, of course, on the other side, we have a steep descent down into the West Fork of the White River. This particular location right here, here's the campus center, is relatively right about there. So we can go back and forth with the world imagery to kind of see this, the campus center right there. And so this high point is just across the street, and this is the Cancer Center. So you can see somewhat, this is New York and University. Kavanaugh Hall, very, very vaguely can you see Kavanaugh Hall somewhat there. Yeah, a little bit, you can kind of see the corner. So one of the things about this particular DEM is it does a pretty good job of showing the surface, but of course buildings are hard to catch, to see. So that's one of the things we're going to see. The advantages of other models is it's good at showing things that are above the surface. So what I did was I asked the GIS, to essentially take this raster, this large, massive image here that's nothing but grids and individual squares. And I said, okay, this is raster. Convert this to a vector model. Convert this into an isoline map. Contour map here of Marion County also shows elevation, but does so differently. So here we see individual lines, and so the same color pattern, yellow representing higher elevation, blues and purples representing lower elevation. We can see the same pattern, higher over here, higher over there, lower in the middle, and lowest down through here. In terms of the isolines, when they are close together, that means a steep gradient. That means we have a very, very steep slope. When the lines are far apart, that's when we see flatter surfaces, flatter areas. And so here, this floodplain throughout much of this area of kind of south central Marion County, it's very, very flat through here. This is all because it's a part of the floodplain of the West Fork of the White River. And so here you can see that the lines are very close. The colors changes quite quickly over in this particular area. So we got some steep slopes over here. Same over there. But we're going to look at IUPUI's campus. We zoom into this particular vector data model, this vector representation of elevation change in Marion County. When we zoom into IUPUI's campus, we're going to see certain places that have higher elevation that are going to be shown in yellow, and areas that have lower elevation in blue, and those steep surfaces, so i.e. the grandstand or the along the shoreline, we should expect to see lines closely spaced together. And indeed that is the case. And so we can see here the grandstand, the higher places here are the top of the grandstand are shown here in yellow. And if we zoom in and the resolution comes, the lines are very close together. And so this represents very, very steep slope. And so a very dramatic descent. That makes sense. This is going down the stairs of this grandstand. And then once we get to the the football field, the football pitch, I should say, it's quite flat. And so this all represents one even surface in which it's all the same elevation. Meanwhile, if we go towards the river, of course, we go down the slope, and then eventually we get to this large area of black, in which there's nothing represented here, and that's because it's the White River. And so this theoretically should be a flat surface from one side of the shore to the other. And so this is a simpler way to represent surface change across IUPUI's campus because we don't see, every single square inch of this particular map is covered with some type of data. So in terms of the vector data model, one of the advantages is it's quite a simple file. I mean, this is not, it's really easy as far as to load and to create this. Whereas the 10 data model, they're kind of bulky and can take a while and hard to export and to move, and so they're big bulky files, whereas this vector data model, this contour line of a map of IUPUI's campus, it's quite easy to move around, although my internet is still quite poor. Here we see the Cancer Center, and of course this is once again showcasing the idea of higher elevated areas. But once again, Kavanaugh Hall, really don't see it too well here. So once again, there's advantages and disadvantages to each of these particular data models. In this case, the contour line has some good things in terms of its quality. It's very easy, it's very quick to show elevation change. But it does have some resolution issues. It doesn't show precision. It doesn't show buildings, the changes in building heights. It doesn't show all throughout the surface undulations. I don't see the pyramid on our campus. I don't see the library. And so that's one of the ideas here, comparing and contrasting different data. Another thing we can do in a GIS is we can go from a raster to a vector by taking those individual grids, so those individual squares, and turning them from squares and just putting a dot right in the middle and using that dot or that point to represent the value of that particular location. And so when we do that, as we see here, the raster to point, our particular geoprocessing tool created this particular grid. And all that is okay, we have our underlying DEF, and it represents these squares that we can't really see too easily here, and the individual squares in which inside them they put a dot. And so you'll note that the raster to point, the vector data model, these points are regularly spaced. So that's something that you'll notice which is different than the triangulated irregular network. So it's another way to showcase, explain a little bit more as far as what do I mean by regularly spaced. And so these grids are regularly spaced, and you can really see that when you convert the grid to actual points. And so what this is a vector data model, and this is a big file, so it's really clunky. So I'm going to try to zoom out slowly so we can see, but nonetheless, notice the dots. They're regularly spaced. Now they're different colors. As we zoom out, that's going to represent different elevation. So once again, now we're just using dots instead of the raster grid cells to represent a